Hi, welcome to this video on Chapter 2 Kinematics. Focus 1 Kinematics Terms and Equations. Here we go. Now, for this topic, the central idea is rate. What is rate? In physics, rate refers to how much one physical quantity changes with time. In this video, we will learn three different rates. They are speed, velocity, and then the later part, acceleration. Let's begin with speed. And to do so, let's recall what we have learned probably in lower secondary or primary school. What is meant by the term distance? So distance refers to how far an object has covered during its motion, regardless of the direction. Very important. So I'm not concerned of which direction it's going. I'm just concerned with the length of the actual path. The standard unit for distance, as we learned in Chapter 1, measurement, is meters. SI unit is meters. Let's look at Figure 1. We have an object at original position P, and that is at time 0. It traveled this path, curvy path, to position R, and that is 15.0 meters. Okay, it reaches R at time 3.0 seconds. So it's just that straightforward. The length of the path taken is 15.0 meters, so the distance traveled is 15.0 meters. Now that we understand distance, let's go to speed. Speed is the rate of change of distance, or we can simply put it how much distance moved per unit time. Now let's quickly come back to here. So the rate we have here is how much distance changed with time. Okay, how much distance is covered for every second. So that's why we say that speed is a type of rate, because you talk about one physical quantity distance, how much it changes with time, in seconds. Now, in reality, we rarely have objects moving at constant speed all the time. Okay, imagine a journey in a vehicle or a train. Okay, the vehicle may speed up, slow down, stop at a certain point, go very fast at another point of the journey. So it's therefore more useful to apply the concept or the idea of average speed, whereby we just simply calculate using this formula, average speed being the total distance traveled divided by the total time taken. Now very quickly, come back to Figure 1. Total distance is 15.0 meters, time taken 3.0 seconds. We can calculate the average speed to be 5.0 meters per second. Now, what does it really mean? Okay, because truthfully, when I tell you this journey, 15 meters in 3 seconds, we do not know at which point did it stop, did it go slowly, or did it go really fast. We do not have information. So all we have is take the 15 meters divided by the time, we got 5.0 meters per second. How you can try to visualize or understand this idea of average speed is, you imagine if this object really moves at a constant speed throughout, then it will be 5.0 meters per second. Now I'm going to move on to the next rate, which is velocity. So before that, we have to learn this new physical quantity called displacement. Displacement is the distance moved in a specific direction. So we started at P, we moved through this curved path, through Q, and then to R. Now, one way to try to understand displacement is to think of it as the change in position. So starting at P and end at R, the change in position is simply this line, okay, indicated by this line. So you can imagine that you are moving from P in the shortest straight line path to R, that is 12 meters. That is the displacement. The velocity is therefore the rate of change of displacement, how much displacement has changed per unit time. Again, we are referring to per second or sometimes per hour. So the SI unit is like the same for speed, meters per second. And then the average velocity also follows that of the average speed. We take the displacement divided by the total time taken. So the displacement is 12 meters, wrong. The average velocity in this case is 12 meters. Divided by 3 seconds, we get 4 meters per second. Now take note that for velocity, we are concerned with what is this direction. So in this case, look at our answer, 4 meters per second to the right. We must indicate the direction. Okay, so let us look at example 1 on average speed and average velocity. You can pause the video and read the question and answers. Okay, so usually if we have a diagram and we have all the information scattered all over the question, it'll be helpful that you just include the data or the information into the diagram so you see a clear big picture of the whole thing. So part A1, I think quite clear cut. From Buena Vista to Dover, distance divided by time, right here, get 18.5 meters per second. The one interesting is A2, from Buena Vista to Dover and then to Clementi. What I want to highlight to you is that we will take into consideration even the time whereby the train is not moving. So even the waiting time is included as the total time. So this would then be the average speed. So part B, calculate the average velocity. So displacement divided by time taken. The displacement from Buena Vista to Clementi, as given in the diagram, is 3750 right here. So divide by the same total time, you get 12.5 meters per second. Now recall that velocity is a physical quantity that has direction. It is speed with direction. So we must indicate the direction. So we have here east. Okay. Now you notice we also have another way to express it, that is positive 12.5. Now why is it so? Because simply I have in this example chosen the right side direction or the eastward direction to be positive. Now the choice of which direction to be positive is completely arbitrary, which means there's no right or wrong. There's no rule saying that right side must be positive. I choose it out of pure random choice. I choose right side to be positive is, in this case, the most convenient because Buena Vista to Clementi is towards the right. So I call right side positive, so I have a nice positive 12.5 value right here. Okay. So both ways are correct. 12.5 meters per second east or simply positive 12.5 meters per second. With the right side being earlier defined to be positive. So part C, you take a read. So we have right now the average velocity for commuter B from Buena Vista to home, which is directly towards the left or eastward. Okay, take note that 3 minutes we convert to seconds. So we take 3 multiplied by 60 seconds, we have this. Now here you notice that we're going towards the west, so you have to indicate the direction, or because right side is positive, so westward will then be negative right here. Okay, so I've actually already explained everything here. So I just want to sum it up. Commuter A, the average velocity commuter A from Buena Vista to Clementi is 12.5 meters per second to the east, or indicated by the arrow here. And then for commuter B is 12.5 meters per second to the west, or indicated as negative. Now in terms of the speed, which is the value, they both are the same. So both of them have the same speed. But in terms of the velocity, because the term velocity includes the direction, so clearly they have different velocities. One towards the right side, one towards the left side, despite having the same value. Okay. Now let's go to this small portion on the conversion of units for speed. Now to convert the meter per second to kilometers per hour, you follow this orange box, you multiply 3.6. Now I'm going to skip the mathematics behind why we multiply 3.6. Okay, so here we're just concerned with getting it done. In kilometers per hour to meter per second, you divide 3.6. So you read example 2, you can pause the video and read example 2. Okay, so what you notice is 2 millimeters per second, you just convert millimeters to meters by recalling from chapter 1 the prefix milli carries a factor of multiplying 10 to the power of -3. Okay, which is equivalent to dividing by 1,000, so you get 0.002 meters per second. Converting to kilometers per hour, you multiply 3.6. Now for the cheetah, 1207 kilometers per hour, you divide 3.6 to get the speed in meter per second. Okay, now it's your turn to try something out to reinforce what you have understood from the previous slides. Okay, so question 1. The actual distance traveled is what I marked out in this yellow path. So you add up to get a total distance, 10, 12, 4, 4, 6, 4, add right here. That's the total distance. Our total time is 16 seconds. You get 2.5 meter per second. Answer is C. For the average velocity, here, this is the displacement from A all the way to G. I know that you can see it is 12 meters, but I'm going to be very careful because north is defined in this question to be positive. So going from A to G is a southward movement direction, so it is -12. So the displacement is negative, you get this value. Now, a little bit tricky because what we have here is meters divided by 16 seconds in total, so it's -0.75 meter per second. But all these are in kilometers per hour, so we do that conversion. You multiply 3.6 to get this. Answer is D. Okay. Now let's move on to the last rate, which is acceleration, defined to be the rate of change of velocity. So how much the velocity change per second? Let's look at the word equation in the green box. It's given by the change in velocity divided by the time taken. Now, in physics, whenever we mention change, we follow the timeline. Change is always now compared with earlier on, just now. Okay, so in terms of the change in velocity, we take the final velocity, which is now, minus away the initial velocity, which is earlier on, which is just now. Right, now we denote final velocity by v, initial by u. So we have the acceleration formula right here. Now the unit for acceleration is meter per second squared, which if this acceleration is totally new to you, you will find this unit very special, or it's like the first time you see such a unit with a square. How do we get that? Take a look at the numerator. The change in velocity, the unit for velocity is meter per second. And you divide by time, the unit for time is seconds. Now if you're familiar with the laws of indices, we have 1 over s is equivalent to s to the power of -1. So when you multiply these two, again the laws of indices says that you add up these two powers, you get s to the power of -2. That is why we have the unit for acceleration, meter per second squared. Now this part here, in your syllabus, they may ask you, or they will ask you, what does it mean when something is undergoing uniform acceleration? So if acceleration is the rate of change of velocity, a uniform acceleration therefore means a constant rate of change of velocity. So the change in velocity is a fixed value. Every second is a fixed value. Let's look at one example, example 3. So here we have the initial velocity being 0, the final being 16, and the time taken for this journey is 5 seconds. You put into the equation, you get this. Now we really have to understand, it cannot be just physics cannot be just formula and numbers to you. You have to know the meaning behind it. So 3.2 meter per second squared, what does it really mean? Okay, it means that the change in velocity is 3.2 meter per second per second. So this second one in words. Okay, I deliberately spell it out in words because we have per second per second. So this one that I'm gonna highlight to you, that is the velocity change in every second. So just tell yourself, every second change by 3.2. 2 seconds, change by 6.4. How about 12 seconds? You take 3.2 multiplied by 12, and that's exactly how we're going to do it here. Okay, you notice that eventually we have 3.2 multiplied by 12. Why is it so? Now we can still use this formula, v minus u over t. You make v the subject because the velocity at time equal 12 is the final velocity in this equation. So we make v the subject, u plus at. U is the initial, is 0. Acceleration, we found it to be 3.2 meter per second squared, or right here. The time taken is 12. Put it in, you get 38.4. Okay, so now it's your turn to try a question. Let's try question 3. Now here the initial velocity is 10 and the final is 2. Now, so obviously there's a decrease in velocity, so the object is slowing down. Okay, so now put the values into the equation confidently. Okay, be very sure what is u and what is v and put it in, despite knowing that the answer is negative. Because what I notice is some students, they see negative, they get a bit worried, paranoid that they can be wrong, so they switch the 2 and the 10, okay, just to create a positive answer. So it need not be the case. That is why the most important part in learning this formula is to be confident which is u and which is v. Put it in, you get a negative value, so be it. Okay, so what does this mean? Once again, it means that every second the velocity changes by negative 0.40. Okay, that definitely means that it is decreasing velocity, so it is slowing down, right? So the acceleration being negative 0.04, answer is A. Here's an important note. Now when we have negative acceleration, it means we're slowing down. Sometimes they may ask what is the deceleration? Now the term deceleration already means slowing down. So when we want to give the value of the deceleration, we do not need a negative sign anymore. So for example, an acceleration of negative 2.5 meter per second squared, the deceleration will then be just 2.5 meter per second squared. One last question. Okay, so how do we deal with this? Now when the dots, because this gadget here, this device is vibrating and punching or creating dots on this strip of paper as the paper moves. So I need to know that when the paper is moving slowly, then it creates the dots. The consecutive dots will be close together. And if it's fast, then the dots are far apart. So if we have slowing down and then speeding up again, we will then see here, slow down, speed up again. Okay, so answer is therefore B. Hi everyone, I hope this video lesson has helped you in re-establishing a solid foundation for this topic. In this way, we can then move on to higher challenges in the theoretical part of the subject. For practical training, we have a fully equipped physics lab to provide hands-on sessions for our students. To find out more, please reach out to us through this media. We will see you soon.